Hello everyone. Today's video will be a review of this step-down and step-up converter. Its output is approximately 80 watts. I bought it on Aliexpress, and today's video will show you all its pros and cons. Despite its power and versatility, the device is compact. It doesn't have its own housing, as it's designed for integration into various power supplies. I received the converter in a cardboard box like this. The sticker contains the device's markings and specifications. The device is packaged in bubble wrap, so it was protected from any damage during shipping. The device is small, attractive, and housed in a plastic case. There are latches on the sides for mounting it into other devices. There are a bunch of different parts on the back. The stepper controller doesn't rotate smoothly. In addition to rotating the knob, you can also press it. The cooler, mounted on a small heatsink, immediately catches your eye. It connects to the board via 2 wires through a connector. The good news is that it doesn't run constantly, but only after the current exceeds 1 amp. The only problem is that the RPM doesn't depend on the load. The fan spins constantly at maximum speed. Next to the fan is a choke, 2 centimeters in diameter and 7 millimeters wide. The wire is approximately 1 millimeter in diameter. All electrolytic capacitors on the board have low internal resistance. Also on the board are 2 LM358 op-amps and a large low-resistance resistor, which most likely serves as a shunt. On the side is a small terminal block and a sticker with the terminal designations. I connected the wires to the terminals and will now demonstrate the device in operation. I apply power to the device. The display shows 2 lines. The top line is the voltage, and the bottom line is the current. On the left is the label OUT. This means the output voltage is now 0 volts. I press the knob, and the load light comes on. At the same time, the signal LED with the word ON lights up. I press it again, and the output voltage disappears. Now the output voltage is 14.18 volts, and the current is 98 milliamps. I turn the knob clockwise, and the voltage gradually increases. If I press the top left button, the parameters displayed on the bottom line will change. Now it shows the current, then the power in watts, the ampere hours loaded into the load during one work session, and the device's operating time. If I hold down the same button, the parameters on the top line will change. Here you can see the input voltage from the power supply and the chip temperature. Pressing the bottom button will take you to a menu where you can change the output voltage and maximum current. Turning the knob will also change the voltage here. But if you press the knob, the cursor will move across all 4 digits, and you can also change them. This way you can immediately set a high voltage without having to turn the knob 1,000 times. Pressing the button again moves the cursor to the bottom line. This sets the maximum current that will be at the converter's output. This is a very convenient feature for situations where current needs to be limited. For example, when working with LEDs or charging batteries. It will also reduce the risk of burning out your DIY project if a short circuit occurs. If you hold down the bottom button, you'll access the options. The first page is called Open. You can set it to either Off or On. If set to All N, the converter's output voltage will be the last voltage set when turned on. If set to Off, there will be no power at the output when turned on. This is where you set the low input voltage protection. If the power supply voltage suddenly drops below the specified value, the converter will shut down. On this page, you can set the maximum voltage limit at the converter's output. If you set, for example, 20 volts here, and then during operation you raise the voltage and accidentally exceed this limit, the protection will be activated. Like on the previous page, you can set the maximum current here. If you set 3 amps here, the device will go into protection mode after exceeding this limit. The converter's power can also be limited from 0 to 82 watts. Here you can set the current limit supplied to the load. By default, the meter is disabled, but if you hold down the knob, you can enter parameters measured in ampere hours. You can also set a timer to control the device's operating time. The range is from 0 to 100 hours. The microcircuit's shutdown temperature can also be adjusted from 80 to 110 degrees. If you suddenly feel that the converter is displaying the input voltage incorrectly, you can calibrate it. The same can be done with the output voltage and current. After this page, the options begin again. Now let's see how the device behaves in practice. In the options, I set the minimum input voltage to 10 volts. If the voltage from the power supply drops below this limit, the device will shut down. The tester behind me shows the input voltage from the power supply at 12 volts. The voltage at the converter's output is 15 volts, and a light bulb is connected to it. I'll gradually reduce the voltage on the power supply. After the voltage drops below the specified value, the converter shuts down after a short period of time. The display shows an error explaining the cause of the failure. After the voltage on the power supply rises, the converter returns to normal operation. But what if the voltage on the power supply has dropped and cannot be restored? To bring the converter back to life, you need to go into the settings again and set the input voltage below 9 volts. This is a bit difficult though, as the display constantly displays an error message. And during all these manipulations, the converter constantly tries to start up, supplying voltage to the load and then disconnecting it again. When I finally accomplished the impossible, went into the options and set the voltage to 5.8 volts, and the converter started working as expected. The output voltage protection works like this. Let's say I set the maximum voltage to 15 volts in the options. I return to the main menu. The converter's output is currently 11 volts. I press the lower left button and try to increase the voltage. As soon as the voltage rose above 15 volts, the converter shut down. In this case, it was 16 volts, but even if the voltage increased by 0.01 volts, the same thing would happen. To restore operation, simply turn the knob and reduce the voltage. Power to the load is cut off during a fault, and after the voltage is restored, all we have to do is press the button. Stabilizing the maximum current is very simple. Let's say we set 300 milliamps in the main menu. I short-circuit the wires, and the current doesn't rise above the specified value. The red indicator lights up. If I set the maximum current to 200 milliamps in the options, and also set the current limit to 300 milliamps in the main menu, then a completely different situation will occur. The device displays an error because the maximum current threshold has been exceeded. In this case, there can be no talk of current stabilization. The operating time limit works like this. I set the limit to 27 minutes. The device has already been running for 25 minutes. At this point, I sped up the video 10x to avoid the 2-minute wait. As soon as the time limit exceeded 27 minutes, the device shut down. Further manipulations are useless. To reset the timer, the only option is to turn off the power. If the counter settings are not changed, the converter will also shut down after 27 minutes. Now I'll test the device for maximum current. The voltage is 14 volts and the current will be 5.1 amps. I'll load it using an electronic load. Note that there are losses in the wires. The voltage on the electronic load gradually drops, but the voltage at the converter output hasn't changed at all. The current parameters also differ slightly. The device handles a current of 5 amps perfectly. If the load is increased slightly, the current stabilizer kicks in, and the voltage drops. If the load is reduced, the voltage returns to normal. Now I've set the converter's output to 20 volts and will test it for maximum power. In this case, it's more convenient to set the output power, displayed in watts, on the second line of the display. When the load exceeded 82 watts, the device shut off. I reduce the load and press the control knob to reapply power. I increase the power and bring it up to 78 watts. The converter maintains the stated power perfectly, and the voltage doesn't even drop. The converter can also be used as a voltmeter, connecting it to various power sources. This thing is also very convenient for charging batteries. Simply set the voltage you need to charge the batteries to in the converter and wait for them to charge. As I mentioned earlier, you can monitor how many amp hours are being applied to the load. And at the end of charging, we know the full capacity of the batteries. As you can see, the red LED lights up on the panel. This indicates that the batteries are being charged with a stabilized current. After a few hours, when the batteries are charged, the voltage will rise to the specified value, and the current will drop to 0. For example, if the meter reads 1000 milliampere hours, it would be wrong to assume that this is the full capacity of the batteries. As we remember from physics, efficiency is never 100%, which means that some of the energy released is converted into heat. The batteries will heat up during charging, so their actual capacity will be less than 1000 milliamperes. This converter costs about $10 on Aliexpress. I think it's a great value for the money, as it combines the functions of several devices and significantly simplifies the assembly of a laboratory power supply. I'll leave a link to this device below the video. If you liked everything, give it a like, click the bell, subscribe to my channel, ask questions in the comments if anyone is interested, and bye everyone.